On the interval from 0 to 2 pi, state the interval where the function is defined. So the first thing that is a struggle in this question is knowing what that means when something is defined. That's asking where are things possible, where are they not possible. We need to list where they are possible. Now there are some things in math that you cannot do, and you've learned this in the past. We have a square root. Are there things you're not allowed to square root? Yes. You're not allowed to square root negatives. So if this is ever negative, that's going to be bad. Well, you can think about your cast rule, and since there's a cosine, can you see that it's going to be bad in quadrants 2 and 3? Anything in quadrant 2 and anything in quadrant 3 is going to be negative, and that's going to be bad. Okay? So that seems to say from 0 to 2 pi, we should be in quadrant 1, and since this is an interval notation, quadrant 1 would go from 0 to pi over 2, and quadrant 4 would start at 3 pi over 2 and go to 2 pi. Now I'm going to put brackets around those in a second, but there's another thing that you're not allowed to do in math that shows up in this question. You can't take square roots of negatives. What else have you learned that you're not allowed to do? You can't divide by 0. If cos is 0, this will be bad. If you think about your unit circle, so now I'm going to just change my cast to unit circle. Cos is your x-coordinate. Can you see that your x-coordinate is 0 at pi over 2 and at 3 pi over 2? So those values will not be allowed. And we would show that in interval notation with a round bracket. In interval notation, if a value is allowed, so for example, right here, at 0 or at 2 pi, can you see cos is 1? Are you allowed to divide by 1? Absolutely. So here we would have square brackets. So there are two intervals where it's defined. It's defined in quadrant 1, but not completely in quadrant 1 because we can't include pi over 2, but we can include 0. And quadrant 4, but we can't include 3 pi over 2, but we can include 2 pi. When you have two intervals, and you'll see this in the answer key, they put a union sign, a U in between, to say that it could be in this interval or this interval. So one of the other things in this question is you're confused about it, then you look at the answer key, and the answer key has a strange looking interval notation, and then you get extra confused about this question. But again, the defined is saying where is it possible. In this question, you need your unit circle and your cast rule to determine where it's possible. Question number 5. Question. Go back. That means or. There's two mathematical symbols. This mathematical symbol means or. This mathematical symbol means and. And I remember, because this one you could almost put a line there, and then it looks like an A for and. So I remember this is and or. It's not so bad. Number 5. This is non-calculator. P theta is a point on the unit circle, then P12 appears in which quadrant? Wouldn't this be nice if this had a degree sign? If it had a degree sign, you could easily say it's in quadrant 1. But when there's no unit, that means 12 radians. Okay? 12 radians is not 12 pi. A common mistake here is students think about 12 pi being right there, coterminal with 2 pi. But 12 is just a number. You have to remember that if you would go halfway around the circle, which is pi, pi is still a number. It's about 3.14. So if you went all the way around at 2 pi, that's 6.28. Can you see that 12 is more than 6.28? If I went and double this, doubling 6.28, gives me approximately 12.56. Can you see that that's more than 12? Okay, so now I'm thinking, ooh, maybe it's in quadrant 4, or do I go back far enough to be into quadrant 3? Well, if pi is 3.14, would you agree that half of that would be about 1.57? And if I went back 1.57 from 12.56, I'd be really close to 11, which means that 12 is in quadrant 4. So we had to do some mental math with radians, but radians as numbers, not numbers with pi. Have I given you a formula sheet yet? Oh. I'll give you a pass out formula sheets. And maybe I'll get you to pass out formula sheets if I can find them. All right, I might have to photocopy and get you formula sheets for tomorrow. I thought I had made them already. I'll get you formula sheets for tomorrow. So, on your formula sheet, you have this formula for arc length, but this formula only works in radians. In section 6.2, we also made this formula if you remember that an arc length is just a proportion of the circumference. So the theta over 360 gave you your percentage or proportion, and there's our whole circumference. This formula is not on your formula sheet. So typically what happens by the end of the year is you forget the formula that's not on your formula sheet, you only have this formula, so then if you wanted to use this formula, we have to change 126 degrees to radians. And how do you do that? You multiply by pi over 180. If you remember one of the techniques, whether to multiply by pi over 180 or 180 over pi, you want the degrees to go away, so your degree signs will have to cancel out. So the 180 degrees would have to be on the bottom. So now we have that our angle is 126 pi over 180. We know that our radius is 20, so our arc length is just going to be our angle in radians times by our radius. Now working with this, if this was non-calculator, I could reduce the 20 and the 180 to be 126 pi over 9. Do we have units in this question? Yes, so we would need units in our answer. If it was multiple choice, they might reduce this even further. You can divide this both by 9. If you divide it both by 9, you get 14. Is that the answer in the back? 14 pi? Yes? So if I reduce it right down, this is an answer that's exact because it keeps pi in it. Okay? If you wanted a decimal, you could go 14 times pi. If you're working with exact numbers, sort of just keep the pi and keep simplifying your numbers along the way. and that would be an exact answer. Number 10. Number 10 is a graphing question that's hidden as not a graphing question. The best way to explain this is if you look at the graph of y equals cos theta minus pi, can you see that that would be a cos graph shifted pi to the right? So I'm going to draw my normal cos graph. I'm going to take my axes family here, pi, pi over 2, and 3 pi over 2, and a maximum of 1 and a minimum of negative 1, right? Here's your regular cos graph. I'll draw it with a dotted line. Cos starts at a maximum, goes to center line, then down to a minimum, back to the center line, and back. And we want to shift this one pi to the right. So I'm going to draw this one in purple. Shifting it pi to the right would give me here, would be where my max, then it would go center line, then minimum, then center line, then maximum, and you can work backwards. There's our purple graph. That's the cos graph moved pi to the right. Next, I'm going to graph y equals negative cos of theta in orange. What does that negative do? That's just a vertical reflection. So your cos graph, instead of starting at a maximum, will start down here at a minimum. Then go center line, max, center line, minimum, and I'll draw that one. I'm actually really happy with how the orange and the purple look next to each other. I think that looks nice. That makes me happy. So graphically, they're exactly the same graph. So because graphically they're the same graph, those two equations are equivalent. What's that? You can change it with an X if you like. Yeah, that'd be fine.
Can I get Zoe down to the office for a moment, please?
Okay.
Thank you.
Down. Yes. Okay. So if you're asked for two different expressions with sine or cos that they're equivalent, one way to do it would be to look at them graphically. On the interval from 0 to 2 pi, where is y equals secant x? Again, we have this undefined. Before we had defined asks where things are possible. Undefined asks where they're impossible. Are there any values that you're not allowed? So the first thing I would do, I would say, well, the definition of secant is 1 over cos. And then I know that I'm not allowed to divide by 0, so can you see that anywhere that cos x is equal to 0, this is going to be bad. On your pi plate, when is cos x equal to 0? That's your x coordinate, that's at pi over 2 and 3 pi over 2. So those would be the values that would be not allowed. So you can, to find where cos x is equal to 0, you can either think about your pi plate or look at our green graph that we drew from before. Can you see that this green dotted graph, which was our cos graph, it's equal to 0 at pi over 2 and 3 pi over 2? So you could also use your graph to help you see some of those values as well. Okay, that's the last one from the... Was the second part calculator? Oh, this one. Hmm? Oh, the first one, I did all the first ones without calculator, and we could have used it. You don't have to use your calculator if you don't want. But you could have used your calculator. I guess for the 126 divided by 9, maybe you'd like your calculator to get that 14. So here, Is 45 on your pie plate? Yes. Sine of 45 is root 2 over 2. It's squared, so this is squared. First temptation in a question like this is that students want to write 1 because they see sine squared plus cos squared. Sine squared theta plus cos squared theta equals 1 only if the angles are the same. But here they're different. On my pie plate, cos of 60 is 1/2. So cos squared of 60 will be 1/2 squared. And now it's just a little bit of algebra. Square root, that'll be 2 over 4. This will be 1 over 4. And we get 3 over 4 in total. This one you're like, it's non-calculator, but 112 is not on my pie plate. However, do you see that these are the same angle? That's how easy it is. If you have sine squared or cos squared plus sine squared or sine squared plus cos squared and the angle is the same, then you can always write 1. And that big idea is also on your formula sheet, which you're going to get more. What is the... Oh, the question was, what's the difference between this and this? This would mean you would take 112 and square. This means the whole thing is squared. So when the squared is in between, it means the whole thing is squared. Anyways, the answer to that one is just 1. This question is really hard because of this part. First of all, you see the cos squared and the sine squared? If you just replace this with a 1, you actually get the right answer for completely the wrong reason. That's why they explain the reasoning is hard. The answer to this question is going to be 3, but it's not because you can just change this to 1. You can only change it to 1 if it's cos squared plus sine squared, and the angle is the same. So that's what makes this question really difficult, is the explain part. And there is some logical thinking and understanding to get the right answer. Okay? Here are some of the things that we observe. Whenever you square something, it's going to be positive. Unless it's 0, because 0 is neither positive or negative. But it's going to be greater than or equal to 0 when you square it. So if we want a maximum, we want to have this big and this small. Because if you're subtracting two things, you want cos squared is going to be as big as possible, and then you want to subtract sine squared to be as small as possible, especially because they're both positive. I mean, if they could be negative, then you for sure you'd want the second one to be negative, because subtracting a negative is adding, but they won't be. They're both positive or bigger than 0. So this is sort of the setup. We make the observation that they're both greater than or equal to 0, so we want cos squared x to be as big as possible, and sine squared x to be as small as possible. On your pie plate, does it make sense that the biggest that cos x gets is equal to 1? Dot, dot, dot. This happens when sine x is equal to 0. Because on your pie plate, when cos x is 1, sine x is 0. That's also going to be the smallest sine squared can be. So the biggest the inside will ever be is 1. And if that's as big as possible, then the max is 3. Because if the biggest the inside of this bracket ever gets is 1, then we would have the maximum being 6 times 1 minus 3, which is 3.
Okay. Lost my mind with substitutes and extras.
Don't
Was I?
It's all good. So the hard part of this one is the explain part. You have to come up with a proper way of explaining why that works. The value isn't so bad. And there are more than one way to explain. I'll just show this as one method. Question number 6. When it gets to your exam, they won't tell you the hint. You'll just have to know the big idea that sine squared x plus cos squared x equals 1. And you'll get really good at rearranging this. For example, can you see that I can rearrange this and get sine squared by itself? By subtracting cos squared. And the reason this is important for this question is currently this question has sine squared x and a cos x. And you can't use the quadratic formula, and you can't factor when they're different. You could factor or use a quadratic formula if you had only sine x and only cos x, but not when you have the two different ones. So what we do is we use the big idea, we use the hint, and we say, well, I could rewrite this whole equation, but instead of starting with sine squared, I could substitute in 1 minus cos squared. Because the big idea tells me those are the same. Sine squared x is equal to 1 minus cos squared x. Now it looks like I have a quadratic equation. For me personally, I like to make one. You always need to make one side equal to 0. I like to make the side equal to 0, so whatever I have that's squared is positive. So I'm going to move everything to the right side. That'll give me cos squared x positive. If I move the 3 cos x to the other side, I'd get plus 3 cos x. If I move my 1 over, I would be left with plus 2. And then this factors beautifully. Cos x and cos x, 2 and 1, they'll both be plus. It's non-calculator, so you go to your unit circle. Minus 1 is on your unit circle. That happens when x is equal to pi. Negative 2 is not on your unit circle, but because this number is bigger than 1, it's not possible. You can't draw a triangle with the adjacent side of 2 and hypotenuse of 1. And I solved between 0 and 2 pi, and it is between 0 and 2 pi. Yay. doing good. Another one with a squared. It's another quadratic equation. You can use the quadratic formula or you can factor, but you need to make one side equal to 0. So I'm going to subtract the tan x over to the other, the root 3 over 3 tan x to the other side. Make one side equal to 0. This part here tells us we're going to need a general solution. How do we do general solution? We first get all of our answers between 0 and 2 pi. And once we have those answers, we add 2k pi to each of them. Again, you can use the quadratic formula, or you can factor. There is a common factor of tan. Take it out, leaving you with tan x minus root 3 over 3 equals 0. Then if we split it here, either tan x is equal to 0, or tan x is equal to root 3 over 3. Is this on your pi plate? Yes. At 0, pi, and at 2 pi. Root 3 over 3 on your pi plate? Yes. It's your pi over 6 family. In quadrant 1 and quadrant 3 because tan is positive. Okay? You can write the general solution either unelegantly, I don't know if unelegantly is a word, or elegantly, which I do know is a word. So I'm going to do it unelegantly. Even saying that makes it feel not elegant. Well, you just list every single one that you have. You would lose there is no loss of marks for unelegance. That would be perfectly fine as a final answer, because that's our strategy. Find your answers between 0 and 2 pi. We found 5 of them. Add 2k pi to all of them. Perfect. Or, if you like to be a little bit more elegant, you might notice that these first 3 can be combined, like this. In fact, you might even note like the 0 and the 2 pi, this is redundant. If you wrote everything coterminal with 0, wouldn't that include 2 pi? And then you wrote everything coterminal with 2 pi, doesn't that include 0? So you like wrote down the same answer again. You don't lose any marks for that. English, you probably lose marks for that. If you're writing an essay and you write a really good paragraph, you're like, oh, that was a good paragraph. I'm going to write it again. You'll be like, I'm so proud of my 15,000 word essay. And your teacher's like, but you have the same paragraph 15 times. It's not a 15,000 word essay. You just repeat it. So it's a little bit less elegant that way. So you can combine these first 3 and these second ones, pi over 6, and this only works, I mentioned this before, that only works with tangent, and because pi over 6 and 7 pi over 6 are exactly 180 degrees or pi apart, you can get them both by jumping by pi's, rather than listing them separately and jumping by 2 pi's. So this is a little bit more elegant just because it's less right. Find the interval or intervals where sine theta is less than cos theta. Justify your response with an explanation or a diagram. I'll show you the best way to solve this one, and then I'll show you a good idea that results in a common mistake. Okay? This one, I feel the best way is to do it graphically. So I'm going to graph from 0 to 2 pi, both sine and cos. I'm going to graph y equals sine x in green. Sine starts in the middle going up. And I'm going to graph y equals cos x in blue. Starts at a maximum, center line, minimum, center line, maximum. And the question is asking, better just delete so I can see, when is the green graph, the sine graph, less than the blue graph? Take out a little highlighter. Can you see that the green one is below the blue one up to there? And then it's below again from here to here. So how do we write this first section? Well, this first section started at 0, included 0, because at 0, sine is less than cos. And it goes up to this point right here. That point is on your unit circle. Can you see on the graphs, that's the point where sine x and cos x are exactly the same, because they intersect. On your unit circle, is there a place where your x coordinate and y coordinate are the same number? That's your pi over 4 family. But I have to use a round bracket here because they are equal there, and the question is just asking where sine is less than cos. And then where are they equal again? Not until quadrant 3, where they're both negative root 2 over 2 and root 2 over 2. 5 pi over 4. And then it's everything up to 2 pi. 2 intervals where it works. This is the right answer. The most common mistake for this question is just using the cast rule and picking quadrant 4 because sine is negative and cos is positive. But quadrant 4 would only give you a little section of this. You've missed part of quadrant 1 and part of quadrant 3 where they're less than. So for question number 9, I find that the graphical way of solving it makes it the easiest. And one thing that this assignment hopefully shows you is that we start to develop sort of 3 main ways of figuring things out. We have algebraic ways, graphical ways, and then just mental math ways. Just maybe you can do some mental math in your head. But usually, the algebraic method and the graphical method are going to be best for solving. But sometimes, like this one, I don't know where to start with algebra. Then look at it from a graph perspective. Or if you don't know how to do it from a graph perspective, look at it from an algebra perspective. But that's one of the things the grade 12 pre-calculus wants you to gain is an understanding of both of them so that you can use it for problem solving. Number 10 is a multi-revolution question. Tan of 3 theta equals -1. So, when we were solving our multi-revolution question, step 1 that we did was we rewrote our domain for 3 theta. So if 1 theta is between 0 and 2 pi, 3 thetas would be between 0 and 6 pi, which is 3 times around your circle. So when you start off with a question like tan of 3 theta equals -1, you can actually solve for 3 theta and say, I have on my unit circle values where tan is -1. That's my pi over 4 family. It's in quadrants 2 and quadrants 4. Because tan is negative in quadrant 2 and 4. But this is only once around my circle. And for 3 theta, we have to go 3 times around our circle. So the second time around, we need to find out what is coterminal with 3 pi over 4. So you're going to have to add 2 pi, and you're going to get really good at adding 2 pi with different fractions. Can you see that 2 pi is equal to 8 pi over 4? And if you had 3 pi over 4 and you added 8 pi over 4, you would get 11 pi over 4. And if you added 8 pi over 4 to 7 pi over 4, you would get 15 pi over 4. That's the second time around. The third time around, if you add 8 pi again over 4, you'd get 19 and 23 pi over 4. And so this is solving for 3 theta between 0 and 6 pi. Then, to get theta by itself, divide everything by 3. Dividing everything by 3 is the same as multiplying by 1/3. And you get 6 answers, and can you see that that last answer is still less than 2 pi? Because 2 pi would be 24 pi over 12, and we get 23 pi over 12. So we get 6 answers for theta between 0 and 2 pi. Go back to this one. Yes. Mm-hmm. You would go, since, right, this one is in quadrant, this is our answer in quadrant 2, and this is our answer in quadrant 4. So I have to get what is coterminal. My circle up here. No, it's not. So here I am at 3 pi over 4 in quadrant 2. The second time around, I need to find something coterminal with that. So I'm going to add 2 pi. And adding 2 pi is 8 pi over 4. So notice that the top number I just added 3, I added 8, I got 11. 7 plus 8, 15. 11 plus 8, 19. 15 plus 8, 23. And our last question. Solve for theta. Sine 2 theta equals negative root 3 over 2. Again, multi-revolution. And this one I'm going to show you 2 methods that you can do because it's a general solution. This question is all on your mindset of how you solve the general solution. The most common way that students do is they first solve between 0 and 2 pi. So this will be identical to what we did in the previous question. If I solve between 0 and 2 pi, then 2 thetas would be between 0 and 4 pi. Twice around the circle, because it's a multi-revolution question. Then I can solve for 2 theta by saying, is root 3 over 2 on my pi plate? Yes. That's my pi over 3 family. Sign is positive, so I would have in quadrant 1 and quadrant 2. But for 2 theta, I need to go twice around the circle. So then I would also get, again, I need something coterminal with this. I'm going to add 2 pi, but this time, adding fractions need a common denominator. I'm going to add 6 pi over 3. So that would give me 7 pi over 3 here, and 8 pi over 3 for the last one. Divide everything by 2. And some of these you could reduce, but you don't have to.
Okay, excuse the interruption, staff and students, but at this time, I'd just like to remind you that outside the office, we are selling ice cream for a donation, $2 or more. All goes to Cancer Care Research, but there'll be ice cream available, and student council will be there helping you scoop it up and getting it to you. So that is ice cream going to Cancer Care. All week this week, we'll be doing things for Cancer Care, but ice cream starts today. Thanks, everyone. Have a great lunch.
Then once you have your answers from 0 to 2 pi, you just add 2k pi to all of them. So this is a very typical way of doing a general solution. You find from 0 to 2 pi first, but it was a multi-revolution question, so we had to solve it like a multi-revolution question to get our answers between 0 and 2 pi, then add 2k pi to each of them. Method number 2 makes your solution look a little bit more elegant. And in the answer key, I've included both types of solutions. So if you did multi-revolution first, it would look like this. I just solved for 2 theta between 0 and 2 pi, which would only be pi over 3 and 2 pi over 3. I write my general solution for 2 theta. Would be pi over 3 plus 2k pi and 2 pi over 3 plus 2k pi, where k is an integer. And if I have the general solution for 2 theta, then I can find the general solution for theta by dividing by 2, which would give me pi over 6, and I have to divide this by 2 as well, plus k pi, and 2 pi over 6 plus k pi. And the answer is a little bit more elegant because there's less things that you have to write. We've done the blue method, the first method, more often, where you solve first for theta between 0 and 2 pi, and then you write the general solution after. Method 2 starts with just, hey, could I write a general solution for 2 theta? And if I have a general solution for 2 theta, I could write a general solution for theta by dividing. And we did it. That was the last one.